So today our topic is long division, and we did long. When did you learn long division? What grade? Huh? Elementary school, fourth grade, right? Okay, all right. So around that time period. So it's been a while, but I believe you still know this. So I'm going to write something here. So I'm going to give you a number. Okay, I'm going to say this: 365. All right, divided by 3. All right, so let's go ahead and do this simple calculation using long division. So using long division, we will write down the, oh, by the way, what do we call this number? Is it a divisor or a dividend? Dividend. And then we put the divisor here, right? What do you do first? So 3 times what would be 3? 1. That's why you put a 1 right here, right? Because 3 times 1 gets you 3, and they cancel each other out. So I think we can, yeah, and then I think we can put a little minus right here to illustrate that they're subtracting. So 0, we don't write it. And then next is to do what? I think you can put 6 down first. And then we ask the same question, right? Okay, so multiply by 2. 3 times 2 is 6. Again, it's a subtraction, so it goes away. There's a 5. Not yet. I mean, the point right here?
No, not there.
Right here?
Yeah.
Not yet, not yet, not yet. We need to finish this first. So 3 times what gets us 5? And we say, well, not really, but we get close to 5 by using 1. And this is what we call a remainder. All right, so how do we present our answer? We say 121 plus what? Not 2. 2 over 3. Now, I want to illustrate one thing right here is that the divisor is here, and that becomes a denominator. The remainder is here, right? And what do we call this thing right here? The 121, what do we call this? The quotient, okay? So I want to make sure that everything is well defined. So we have this as a dividend, no, divisor, sorry. Divisor. And this is a dividend. All right, so far so good? Yes? All right, now, what we're about to do today is actually exactly the same as this. Exactly. It just looks a little bit uglier than the pure numbers. And I'm going to show you how they are exactly the same. So, for example, okay. Now, before we do any long division, can you see something special? Yeah, so let me go ahead and factor out the 5. Or actually, yeah, let's go ahead and factor out the 5 first. Okay, because that is not very pretty. Okay, and I'm going to do this, and okay, all right. So not only the dividend could be factored out with a 5, the divisor could also be factored out with a 5. So the 5 actually got canceled out. So now we say, all right, perform a long division. How do we perform long division? Well, this is how we do it. Now, the way you see it is this. With a polynomial, okay, so an example of polynomial would be like 5x cubed plus 3x squared minus 7x plus 4, for example. Now, this is polynomial. You probably don't really feel much attachment to it. But what I want you to see is that, can you imagine this as a 4-digit number? Like there are 4 slots, right? Imagine that it's a 4-digit number. So this is what we would do actually. We'll say, all right, well, we are going to write down our long division right here. And now it's missing a constant term, so we have to fill it in. So what this does is that we are actually doing this long division problem as if, in this case, a 4-digit number being divided by a 2-digit number. And our thought process is exactly the same as what we did over here. Exactly. All right, now think about how we get the first one. We try to get the 3 canceled out, right? Yes. Well, because for a polynomial, it's always like x to the highest power, and it goes by the descending order. And the very last one, it's a constant because it's like x to the 0 power. Okay. So we ask the same question. Hey, we want to get rid of the n cube, and we have a n right here. So n times what? It's n cube. N square, right? So therefore, we will write down n squared times n will be n cubed. That will be the first quote unquote digit. And then to multiply to the second quote unquote digit will be n squared times 1 is n squared. Now, and this is what I would do. And I would like you to adopt this method. What I would like you to do, you show your minus and you put a circle around it. And I will tell you why, which I love to explain the why. Why do you put well, first, if you don't put a minus, you may forget that it's subtraction, number one. Number two, I always put a little circle around it because if I don't, you know what's going to happen if I don't? It's like negative only for the first term only. So I want to make sure that everything goes past by this minus sign. So n cubed minus n cubed, they cancel out. Nice. Minus 2n squared, negative 2n squared, minus n squared. No. You got negative 3n squared because it's subtraction, okay? So if you don't make this minus very sharp, very stand out, what could happen is that people would just look at these two things together and they would just, add the n squared to the negative 2n, and that's going to mess up the whole calculation. All right, so I'm going to pause for a moment right here to make sure that you understand why we have the n2 at the top and why we have a minus 3n squared right here. Yes.
Are you sorry? So the n cubed and the 2n squared, are you treating it as like its own like segment?
So this times this gives you n cubed, and this times this gets you n squared. So that's why I said it's like a division with a 2-digit number. The same exact operation, basically. And then once we have this, we say, all right, let's go ahead, bring down the next digit. Okay, bring it down. So now we have 2 digits again. And then we say, all right, n times what? We give you a negative 3n squared. We say, well, negative 3n would do the job, right? Negative 3n times n would be negative 3n squared. And then negative 3n times 1 would be negative 3n. Well, guess what? Do they look very similar to each other or identical to each other, right? So they cancel each other out. And actually, that's it. So what's the answer? N squared minus 3n. All right, now I'm going to follow up with a question, with a quick question. And I want you to write this question down as well. Is 5n plus 5 a factor of 5n cubed minus 10n squared minus 15n. Now, if you find this a bit challenging to answer, I can give you an alternative one, which is it's 3 a factor of 18. Yes or no? Yes or no? It is a yes. But how do you know it's a yes?
Oh, 3 times 6.
We can say 3 times 6 is 18, or you can say if you divide 18 by 3, you got 6, and the remainder is 0. So I want to bring out the importance of remainder at this point, that whenever you see the remainder being 0, it actually reveals something very special, and that is, hey, whatever you just divided, it's a factor. And what did we do for the past couple of days? Factoring. So that's how these things are coming together. So I'm going to do a few more examples and then see if you can really capture the process. And I hope you can really see the parallel here, that whatever we're doing right now is just like the ones that we had done back in elementary school, except that it's more sophisticated because you are going to be more sophisticated. All right, so let's move on to number 2, all right?